There are three trigonometric graphs that you'll have a look at for GCSE. One of them is the tangent graph. I call this the tan swoosh because it goes swoosh, swoosh. You've then got the sine wave. So it waves up and down like a sea wave. And then you've got the cos bucket because it goes like that. Now, all three of those graphs are what are called periodic graphs, and they will go on infinitely. So the sine wave will continue to wave up and down. And in fact, once you're past 360, the cos starts to look like a wave as well. But if we just look at the first chunk of it, that first 360, it just looks like a bucket. So sine wave, cos bucket, tan swoosh. That's what I call them anyway. So that's basically to explain what I'm on about if I talk about a bucket. Okay, so tangent can go out the way because this one is just about sine and cosine. So, for the first set of questions, you've been given one value of the solution for sine x equals blah, and you need to find another solution within the period of 0 to 360. Now, because this graph goes up and down and up and down and up and down forever, there are an infinite number of solutions to any trigonometric equation, sine x equals blah. But we are only asking to find two of them, one of which is given in between 0 and 360, which is why we've only got this part of the graph. So it gives us the first answer, which is really helpful because it means we can clarify, we can check with ourselves. So 33 degrees is about here. And that kind of matches up with 0.54, doesn't it? Now, just to be clear, I've printed this out. But in an exam, you might not be given the graph. In fact, you probably wouldn't be given the graph. So you need to make sure you are happy to do a little sketch. Now, a sketch does not have to be neat and accurate like this. It literally has to be like that. And you need to know that this point here is 0, that this point here is 90, that this point here is 180, this point here is 270. And that point there is 360. That is literally all you would need for a sketch in an exam to help you. Okay, so I've got this posh one here, doesn't matter. It's just because I don't want to have to draw it out. How many times did I do it? Oh my goodness, I'm definitely not drawing it out 12 times. Anyway, I digress. So you look at where you're talking about. This is the point we're talking about, where x is 33. We now have to work out when is the graph at that height again. And we can see it's here, over the other side of the first bulge of the wave. And that's going to be there. Now, we could say that's about 150, but we need to be a bit more accurate than that. It wants it to the nearest degree. So, we think about where this answer is. This answer is 33 degrees away from 0. So it follows that this answer must be 33 degrees away from 180 because the graph is symmetrical. So to find my answer for this one, I'm going to do 180, subtract 33, which gives me 147. Next question. Now this time we're told that the first one is 59 degrees, which should be just before 60 there. That looks right, doesn't it? About 0.86. Like I said, not perfect. Doesn't have to be perfect. Probably shouldn't use felt tip in an exam though. When is it that height again? Over this side. Let me go back down. It's there. We can either count forwards from 0 or we can count backwards from 90. Doesn't matter which, as long as we're using one of those 4 points that are really, those 5 points that are really important on the graph. 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So, I'm going to use 90. This, I know, is 59 degrees. So how far away is that from 90? And that's 31 degrees backwards from 90. So my next solution is going to be 31 degrees onwards from 90. So 90 add 31 gives me 121. Okay. Let's have a look at this one. This one's got a negative answer, so we could say depth rather than height. I don't know. So negative 5,9, and the answer it's given us is 216. 216 would be about here. Yeah, that kind of makes sense. Negative 0.59. We know that this is 216. And we want to know what this is. So we can either count onwards from 180 and then backwards from 360, or we can count forwards and backwards from 270. I'm going to count forwards from 180, which is 36 degrees. Which means I need to count backwards from 360, 36 degrees. So I do in my head or on a calculator or on paper, I would do 360 take away 36, which gives me 324. Always check your answers are between 0 and 360. They will be in this case because they're on the graph, but sometimes it will stay between 180 and 360. You need to be really careful. They will try and catch you out because they're nasty. Last sine one on this page. The whole page was much bigger, but I wanted little graphs, so I cut them all out. Negative 0.81 down here somewhere. That kind of makes sense, doesn't it? 118. I've lost where I am. No, I'm looking at the wrong question. There we go. 234. That makes more sense. My goodness, what's going on with me today? It's about there. Okay. Ish, and then that's going to be here. So this is a bit behind 270. How far behind 270 is it? It is 36 behind 270, which means this next one needs to be 36 forwards from 270, which gives me 306. You might notice that the answers are complements to 10, so 3 and 7, the units digits, 9 and 1, 6 and 4, 4 and 6. Now onto the cos bucket. Here we are. Same idea. It's a symmetrical graph, so we can use that to help us. So x is 23. That's going to be about here. Ooh, very high. Other place it's going to be, that value is over here. Right, so this is 23 degrees away from 0. This is going to be 23 degrees away from 360, which means it's going to be 337. 0.62 is our next one. And that's about there, which is 52 degrees, apparently. And we're interested in the next time it's that, which is there. So we can either say it's 52 on from 0, or we can say that it's 38 before 90. I much prefer saying it's 52 onwards from 0. It really doesn't matter which way you do it. Either way will give you the same answer. In fact, that's a good way to check your answer. Do it both ways. Make sure that they match up. 360 take away 52. It gives me 308. A negative answer now. A negative value, now, of negative 0.47. About here. We know that's 118. When is it that again? Over here. Well, 118. That's a bit further on from 90. In fact, it's 28 on from 90. So I need to count backwards. Backwards from 270. 28 backwards from 270 is 242. Again, you'll notice that the units digits are the number bonds to 10. And last one on this page, negative 0.92. Down here. 157. That's closest to 180, so it makes sense to do that. How far away from 180 is 157? Well, it is 23 away, which means we need to move 23 further on. 180 add 23 is 203. So there's our first page. That was easier because they'd given us all of the first answers. However, when they don't give us the first answers, the only extra bit we need to think about is using our calculator, which at this point we should hopefully be quite good at. So sine x equals 0.01. We want to know what x is, which means we need to undo that function of sine. So we're going to do shift sine, sine inverse on our calculator, and then inside the bracket 0.01. 0.57. I've done something wrong. No, I haven't. Ignore me. So that's quite small. 0.57 is 1 degree. So now I take my sine graph. 0.01 is... It's there, isn't it? That's just... I can't even draw that. It's too tiny. So that's 1 degree. The next time it's going to be that high is here. If that's 1 degree after 0, this is going to be 1 degree before 180, which means it's going to be 179 degrees. Let's look at the next one. Sine x equals negative 0.78. So back onto my calculator. Sine inverse negative 0.78. Always suggest that you use this negative rather than the subtract button, but it does depend on your calculator. Some of them are more fussy than others. Negative 51 degrees. Hang on a second. My answers need to be between 0 and 360. So I'm not going to write that in that box because it's not between 0 and 360. In fact, you might say, I've never heard of a negative angle before. What's going on there? We'll have a look. Remember I said that these graphs were periodic? That means that they repeat until infinity. They repeat backwards from backwards to negative infinity as well. So that is what's going on there. Now, if I'm at negative 51 degrees, which is over there, that is 51 degrees before 0. So I'm just going to imagine where that would go. It would kind of go down like that, wouldn't it? Because it continues with its wave. When is it that height again? Oh, over here. Okay. Right, so negative 51 is 51 away from 0. So this answer here must be 51 away from 180. So I need to do 180, add 51, it gives me 231. Much better. You'll notice that these two don't have don't have number bonds to 10 units digits. However, these two will, because they're on the same part of the line. Whereas the next point is going to be here. And that's going to be 51 before 360, which is 309. There you go. See, told you. These two add up. 0.53 is here. Let's just check on our calculator. We're on cos now. Make sure you're always using the correct trigonometric function, otherwise you'll get completely the wrong answer. 59 degrees. Just check, is that between 0 and 360? Yes, it is. 59 degrees. Sorted. So, look at my graph. Where is 59 degrees? 59 degrees is here-ish. That makes sense, doesn't it? 0.51. Remember what I said? These graphs are not drawn accurately. You do not have to be accurate. You just have to get an idea of whereabouts it is. So I can see that 51, well, it's... Sorry, I heard family. It's 31 degrees away from 90, which means that this answer here is going to be 31 degrees away from 270. So we do 270, add 31, gives me 301. And finally, we have negative 0.03. So cos inverse negative 0.03, 91.7, that's 92 really, isn't it? And then we look at our cos bucket for the final time. 92, well that's 2 degrees on from 90, which means that this one is going to be 2 degrees before 270, which is 268. Again, the important things to notice, if you get a negative angle, make sure that you extend your graph back beyond 0. Make sure that your answers are all between the degrees you've been given, and make sure you're using the correct trigonometric function.